think you already, somebody already said yes. We are just 12 now attending class. So far we are 8. We are 10, including the instructor last night.
Okay. All right. So let me share the screen and
This meeting is being
begin the
recorded.
session.
Thank you, anyone.
Yesterday we were discussing about
Can review.
conditional probability, right? And we have discussed various things, z score, z table, right? And the probability associated with these z scores. We also discussed how this confidence interval is being calculated, right? And along with this,
Just make sure you don't drop from.
uh, the next topic we do have is hypothesis testing. So in hypothesis testings, we have different agendas: flowchart when y is continuous, then test cases for continuous variables. Then we also have flowchart when y is discrete. Then test case for discrete variables, parametric versus non-parametric test cases. And I hope you people are aware about what is parametric models and what are non-parametric models, right? But the very first question is, what is hypothesis testing? What do you mean? What is the requirement of this hypothesis testing? Anyone? So in simple words, it is a statistical method to make some inferences about the population parameter based on the sample data. And there are various steps it involves when it comes to hypothesis testing. So basically, the overview of this hypothesis testing is to take the business related decisions. To take the business decisions,
Coding.
we
So
apply hypothesis testings. For an example,
you took away my.
suppose as a bank, you should launch a new credit card, or you should continue with the existing ones. If you launch a new credit card, it means action has been taken, right? You launch a credit card, it means you are going to take a action. And if you are not launching it, if you are going with your existing policies, existing credit cards, it means you are not taking any action, no action. Keep it as it is. Whatever is running into the business, do not take any actions. Let it go as it is. So based on these two parameters, we take decisions. When you take a decisions,
Okay.
this is called as alternate hypothesis.
Okay, I'll forgive your license. Okay.
And it is
Might be
represented
the
by HA.
document of the car.
HA means you will take a decision. When you do not take a decision, no action, no decision, no action has been taken. In this case, this is also called, this is called as null hypothesis. It is represented by H naught. So null hypothesis means no action. Alternate hypothesis means you are going for alternate solution and action has been taken. Now this testing will help us to identify whether we need to take, we need to take an action or we do not need to take an action. If you are taking an action, it is called as HA. If you are not taking an action, which is called as H0. That is alternate hypothesis and null hypothesis. Do not take any action, null. That is called as hypothesis testing to come up with a business decision. Is it clear? Now, to perform hypothesis testing, you have various different components. Let's say when y is continuous, your output variable is continuous, you will be having a different test. When y is discrete, or you can call it as categorical, you will be having different method or technique to calculate the perform this testing, right? So for different types of output data type, you will be having different methods of hypothesis testing. That is also we will discuss. So there are two types of parameters in hypothesis testing. That is two types of hypothesis, that is null hypothesis and alternate hypothesis. So first you start with hypothesis about a population parameter. You collect some information in these two parts. Now what is happening? Are you going to reject or you are not going to reject? Now this is the same thing. If you fail to reject H naught, what is H naught? H naught means null hypothesis. And what null hypothesis is saying? No action will be, sorry, no action has to be, that is null hypothesis. Now if you are rejecting, this null hypothesis, then what you are accepting? It means you are accepting alternate hypothesis. And if you are accepting alternate hypothesis, it means you are going to take an action. So I will say action taken. If you are rejecting this, then obviously you are taking considering alternate hypothesis or vice versa, right? But here it is saying fail to reject H naught. We are not rejecting, we are failed to reject it. It means no action has been taken. If no action has been taken where H naught is true, here what is happening? I am not rejecting null hypothesis. I fail to reject it. It means H naught is true in this condition. So both of this and this statement are same. And this type of is called as right decision has been taken. The decision has been taken, right decision, and in this is the confidence 1 minus alpha. Then when you are going to Rome, this is similar to your confusion matrix. I explain confusion matrix. It is little bit similar to this. Now when you reject null hypothesis, if you are not going with H naught, then you are accepting alternate hypothesis, means you are taking action. If you are rejecting null hypothesis, but here H naught should be true, then this is your type 1 error, which is alpha. Because here it is no, here it is yes, right? Both are opposite. So it is type 1 error. This is not a right decision. Here it was right decision where both were yes and yes. So this is your type 1 error. This your action, that the action you are going to take, it is not correct. You are thinking to launch an credit card, right? You can be considered as a false positive or negative or whatever in that way also. But yeah, we will talk in terms of false this type 1 error, right? Because in actual it was true, but we are rejecting this null hypothesis. We are accepting alternate hypothesis. So this is type 1 error. Then next, what we are saying, we are going with null hypothesis, means we fail to reject it, and hence we are accepting null hypothesis. But here HA was true. Here this should be gone with alternate hypothesis, because here also it is true. So this is your type 2 error, that is beta. Here it was alpha, here it is beta, diagonally. False negative, false positive, yes. And here what is happening? If you are rejecting null hypothesis, means you are going for alternate hypothesis. And here also it is saying that yes, go with HA, which is true. Go with alternate hypothesis. And this is your right decision power. The right decision has been taken. So in simple words, this is these two are matching, and this one and this one are opposite. It is similar to your confusion matrix. That is what I said. In that way, you can read and understand this part also. So the factor that affects the power of a test, it includes sample size, effect size, population, variability, and uh, the value of alpha and beta. So this is again the calculation part. And the maximum power a test can have is 1, where the minimum is 0. So here we will be having a chart or the use case. For an example, our quality will not improve after consulting project. Again, this is something related to business decisions, right? What business decision we need to take? If we are taking a new action, new decision, it is alternate hypothesis. If we are not taking any action, it is null hypothesis. Means you are continuing with whatever business you have in the past. So these decisions will be taken using hypothesis testing. So here you have a use case. Our quality will not improve after consulting project. So our potential customers do not spend more than 60 minutes on the web every day. This is also another question. We will need 400 more person hours to finish this project. Now this is a question mark. Should we go ahead and hire 400 people or not? Action is to be taken or not taken. Then you have less than 5% client with default on their loans. Should we give them loan? Here it says we will acquire 8,000 new customers if I open a store in this area. Now, you should open a store or you should not open a store? What decision you are going to take? These decisions can be statistically taken using this concept of hypothesis testing. Should I, if I know that 5% of the client will default on the loans, should I give them loan or should I not give them loan? Should I hire 400 people or I should not hire 400 people? The retail market will grow by 50% in the next 5 years. So should I invest into retail business or should I not invest into this business? It's not, I should not take any action or I should go and take any action. This is something will help us to take the business related decisions. So these are the use cases of hypothesis testing when it comes to business decisions. Now this is a flow chart we do have. What is happening over here? When y is discrete and x factor is discrete, means y and x both are discrete. And what is the definition of discrete? It should not be continuous, means the data which should not be represented into the form of decimal. That is called as discrete data. Let's say one car, one laptop, right? Um, Many bunch of other examples we do have. So these are the discrete data or the categories, right? Male, female, and all. So when y and x both are this, what we do, we compare one population with external standard, two population with each other, and compare more than two population with each other. So you will be having a proportion test, two proportion test, and chi-square test or chi-square test, whatever you want to pronounce. Now, what is this two population? This is y. What number of classes you do have in y? You want to predict whether a person will default or not default. This is two class, binary class problem. If you want to predict the salary, whether it is high, whether it is low, whether it is medium, this is three class. And then you have multi-class classification problems also. So based on this also, you have different types of tests you can perform. Similar to that, you have another flowchart where y is continuous. Now y is continuous and x is discrete. Y is continuous means the number which can be represented into the form of decimals and which makes sense. Let's say salary. Salary is a continuous data type because you can represent it in the form of decimal and it makes sense. When it comes to discrete, you cannot say a 1.5 car or 1.5 laptop, right? It does not make any sense. So this is your discrete data. When you say 20,545.3 something, 30, this can be a type of salary, right? Or currency. So this is a continuous data type. So when it comes to continuous data type, compare one population with external, compare two population with each other, compare more than two population with each other. Then you also check where y data is normal or not normal. If data is normal, then you go and check standard deviation. If it is standard deviation is sigma, which is known, then you perform sample z test. If it is not known, then you perform t-test. That is what we have already discussed. If sigma is known, we refer z table. If sigma is unknown, right? If sigma is unknown, then we prefer t table. That is student table we prefer. Similarly, if y is not normal, then there is something called a sign test. There are bunch of tests. We will not deep dive into this, but yeah, this is something we do. Then when y and y2 are normal, sorry, whether y and y1 and y2 are normal or not. So if they are normal, check for the external conditions. Is it same or it is not same? If it is same, go for t-test. If it is not, then you check the variance. We have something called as ANOVA, analysis of variance. This one, ANOVA test, which stands for analysis of variance. So you go for the variance. If it is equal, you perform sample T for equal variance. If it is not equal, then you perform sample T for unequal variance. And you have when more than two populations, when it is normal, again you check for variance. So for if it is equal, then you go for ANOVA, analysis of variance terms, when variance is equal. If it is not equal, then you go for ANOVA. And this is another class. If it is not normal, then Moore's median test. There are a bunch of things we do have. If you remember, it's fine, but yeah, you should have a basic knowledge of these things, that when it is discrete and when it is continuous, what kind of test you are going to perform. So ANOVA test is very famous when it comes to continuous data type. And chi-square test is something you perform when it comes to discrete data type. When y is discrete, you perform chi-square test or chi-square test. When it is continuous, you perform mostly ANOVA, but again, it depends on the data whether it is normal or whether it has equal variance or not. Now, this is little bit tricky, but yeah, this is something we do have. So this is the flow chart. Then you have one sample z test. For one sample z test, you have normality test, you have population standard deviation. You check whether it is known or not known, and then you perform sample z test. So on this type of fabric data, you can perform z test also. You can have normality test. Normality means you will check whether data is normal or not normal. You check whether sigma is known or unknown, and then you further go ahead and check with z test. So here the explanation has been given based on fabric data. First, you check if it is continuous, and yes, it is continuous. Fabric length is continuous, discrete one population. What is X? You check. So you have 25 samples of fabric are taken at random. Mean and standard deviation from historic 2 years study are 150 and 4 respectively. The mean and standard deviation has been given, and alpha is 0.05. So fabric length is continuous, right? So we will go with this continuous when y is continuous. We are comparing mean with external standard of 150 meter. Then data was shown to be normal. If it is normal, then we will go with this part, not with this. Then you go and check population standard deviation. Yes, it is known. You perform z test. If it is unknown, you perform t test. So based on different condition, we will follow the flow chart from this. Okay. You need to identify if it is given or not given. Now here sigma is unknown. So we will perform t test. What it says on energy cost, you have 25 families which are being analyzed for the monthly energy cost, and you need to determine whether the monthly energy cost has changed from the previous year when the mean cost per month was $200. It has been changed or not, we need to test. So conduct a test to check whether 95% confidence that mean is not different from the specification values. Now here sigma is unknown. We do not have sigma, if you have noticed. Hence we are performing t test. If sigma is known, we will perform z test. If sigma is unknown, then we will perform t test. Rest of the process will be as it is. The first, you need to check normality. Second, you need to check whether population standard deviation, that is sigma, is known or unknown. Then you decide whether you want to go with Z test or T test. Again, the same thing. This is for sign test. You have normality test, non-parametric sample sign test, and here you have chromium percentage, means a sample of stainless steel set of 12 is taken as a random. Percent of chrome is present, that is something we do have. And a metallurgical engineer conducts a test to determine whether the medium chromium contained in a set of stainless steel sample is equal to 80% or not. Basically, we need to check the chromium percentage. And we need to identify whether this medium chromium content is different from 18% at a 5% significant level. 5% significant level means you have 95% confident interval. Okay, so do not get confused. 5% is the chance of going you wrong, means you are 95% confident that you are going to create 95% of the confident interval. And when you have this kind of data, then you perform, you check first for the normality test, and then you go for the non-parametric sample sign test. So given based on the different business conditions, business problems, you have different solutions and different methods as well as techniques. Then you have Mann-Whitney test for medians. And when you have such kind of problems, vehicle with and without additives. Effect of fuel additives. Additive means if you are adding something in your fuel, let's say oil, then how it is going to affect your vehicle. So effect of fuel additive on vehicles is being studied. Out of total 20 vehicles, 10 vehicles are chosen randomly and mileage is recorded. While in rest of the 10 vehicles, additive to be tested is added with the fuel and their mileage is recorded. Find if the mileage increased by adding the fuel additive or not. So for that purpose, we will perform Whitney test for medians. Right? Whether if you have 20 vehicles, for 10 you calculate the mileage, and for another 10 you add, let's say if you have a fuel petrol, you add something additive, let's say oil, into the petrol, and then you check the mileage. Then you compare this with this, whether it is increasing or decreasing. Now additive does not mean oil, you can add any other additive chemical. So we have this Mann-Whitney test to perform this kind of tests. Then you have two sample t-test, where you have normality test, variance test, and sample t-test. Again, in normality test, you check whether data is normal or not non-normal. How you will check whether data is normal or non-normal? Using QQ plot, right? If it is normal, you will go with variance test. If it is not normal, then you will go with another option, another method. Then you will check variance, if it is equal, if it is not equal. For two different conditions, we have two different methods. Then you will go for sample t-test. T-test is again related to student t-test, or from student table we have sample t-test. And here the business problem is marketing strategy. So here it says a financial analyst at a financial institute want to evaluate a recent credit card promotion. And after the promotion, 500 card holders were randomly selected half received an ad promotion, a full waiver of interest rate on purchases made over the next 3 months, and half of them received a standard Christmas advertisement. Does it mean that if this ad promoting full interest rate waiver increases the purchase of the credit card? This is something we are testing, that whatever uh, ad was used for the promotion of the card, was it effective to influence customer to make purchase of this card? Is it because of this promotional offer?
This
The credit
meeting is
card.
being recorded.
Is it because of this customers are moving to? Customers are taking this card. If obviously yes, then obviously such kind of more promotional strategies will be there into the business, and obviously bank will try to influence or convince the customers in some other promotional strategies, right? So whether this is something we can understand using the test only, whether this is effective or there is some other reason why customer liked our card, right? So we will perform a test and then we will get to know on these kind of things. That is two samples. So this is also the same thing. Y is continuous. If it is normal, you will go with variance. If it is equal variance or unequal variance, equal variance, you will go with ANOVA test. Right? The same thing. Flow chart when Y is continuous. Then you have this modes median test, the normality test, modes median test, and you have further study about this. Fish dose. Now here this is another business problem. A study specified that temperature changes in the ocean affect the growth of the fish. And one of the scientists divide 25 newly hatched fish into 4 groups and place each group into a separate simulated ocean environment with temperature variations. And after 6 months, he has observed the weights of the fish to determine whether the median weight of the fish is differ among the 4 different groups when it comes to change into the temperature. So obviously, if you will keep of all of these 4 different groups, or you will take one of them randomly and put it into a different uh, environmental or temperature conditions, and then you will weigh those fish. What is the weight of this fish as compared to this and this? And when you will take an average, obviously you will identify that what is the effect of this temperature. Is it positive or it was negative when it comes to weight of the fish? So this is something you can identify using Moore's median test, because you are taking median average in this case. Median weights of the fish you are going to take and compare. Then you have one way ANOVA. Now ANOVA stands for analysis of variance. Here you have a business problem, contract renewal. A marketing organization outsource their back office operation to through the 3 different suppliers. The contracts are up for renewal and CMO means Chief Marketing Officer. You want to determine whether they should renew contracts with all supplier or any specific supplier. And you want to renew the contract or supplier with the least transaction time, whose performance is the best. And he will renew all the contracts if the performance of all the suppliers are similar. So obviously variance comes into the picture. Hence, for this we have ANOVA, which stands for Analysis of Variance. This is called as ANOVA. We will find out the variance of each of them, of each of these suppliers, and identify. And then we will find out that with which the contract is going to be renewed. This is also the same. So there are one example. I'm not sure where it is. It is not given. Okay. So this was ANOVA. This is the same graph. Then you have weight reduction program, and a nutrition expert would like to do a evaluation on 3 different diet programs. These are the 3 different diet programs, and it will assign to the volunteers randomly. It will select, and they will assign a equal number of participants to each of these programs, right? And the average weight loss in each of these groups are 4.5, 7, and 5.3 kgs. So in this case, what she can conclude, the nutrition expert, what she can conclude when it comes to uh, weight reduction program to 3 different volunteers. Now this is something your task. I'm giving it to you. You need to identify it, do a homework, that what should be the solution to this. Okay. You can come up with what is your thinking when it comes this thing in your mind. Based on this, you can have a conclusion. This is something the scenarios has been given. 2 different scenarios. One group is represented by square, circle, and rectangle, and these are the average weights. That is not required. So now about analysis of variance, we do have. So analysis of variance, as I said, ANOVA. It can be used to test equality of the means where two or more, when we have two or more than two population, and it can also be used with one or two factors. If you have only one factor which is varying, then you use one way ANOVA. There are 2 types of ANOVA and one way ANOVA. For an example, if you want to uh, compare the mean performance of several departments within a company, let's say you have HR department, you have sales department, you have admin related things, right? Then you have processing department, operations, right? You want to compare the performance of each of these departments. So here the what is the factor? The name of the department. One factor is there. So you will apply one way ANOVA because there is only one factor. And what is that one factor varying? The performance of each of these departments. For an example, if there are two factors. When it will be two factors, we should use two-way ANOVA. For an example, one factor is the department, and the second factor is the shift, whether it is a day shift or night shift. So HR department within which you have day and night, right? But in HR we generally do not have. When it comes to um, operations, whether you have day shift or night shift, right? So name of the department is one factor and shift is another factor. So two factors are there. And when we have two factors, you apply two-way ANOVA. So you have one-way ANOVA and two-way ANOVA. One-way ANOVA means one factor. Two-way ANOVA means when you have two factors. So ANOVA can be used with one or two factors. This is something we already discussed. So this is your null hypothesis and this is your alternate hypothesis NC. And there is something called as p-value, which is significance level. And generally you can in master class also this hypothesis testings will be there. So you have significance level, we say p low, null, go, p high, null, fly. Now this will be an important term, you will understand it later. P low means P is something represented using significance level. Chance of going U is wrong is your P value, which is 0.05%. So if P is low, null will go. Means if P value is less, then you can go ahead and take an action. Obviously, if chance of you going is wrong, then you will go ahead and take an action. But if P value is high, then null will fly. Means you will go with null value. You will not take any action. No action. Because P value is high. And what is P? P is your significance level. Means chance of going U is wrong, which is greater than 5%. Industry standard is 95% confident. You can go 5% wrong. You cannot go wrong beyond 5%. So if this P value is greater than 5, then you should not expect or you should not take any action. You should go with null hypothesis. No action has to be taken. If P value is less, then you can reject this null hypothesis and you should go with alternate hypothesis. This is another two proportion test we have. Then you have chi-square test, chi-square test. These are the things. You check P values when it is H naught and you check HA. If P value is less than alpha, we reject it. That is what I said. P low, null go. P high, null fly. If it is less than alpha, what is alpha? 5%. That is, if P is less than 0.05%, P low, null go. We will reject null hypothesis. We will go and take an action. So in simple, that is what I said. P low, null go. P high, null fly. Write it in your notebook. And this is another use case. So I will write it over here once again. We can make a note of this. When P is low, null will go. When P is high, null will fly. Fly means you will go with null values. P low null go means you are rejecting null hypothesis. You are going with null hypothesis. And P is your significance level. Chance of you going wrong. And it should not be greater than 5%. And like it should be less than or equal to 0.05 or 5%. Now these concepts we are going to apply in regression models because this is our next topic of discussion. Okay, so let's go with the where is this? First, we will do the code part of this. So download this one, the coding part. Open your Spider. Spider, you can open. A small code is there for confidence interval we will have. For hypothesis testing, it will be covered in your this part, master class. Okay. So let me open it from here. Downloads. Then we have the file. We have this confidence interval. Only this small code we do have when it comes to confidence interval. Import scipy dot states as states. Then now what is happening over here? You need to. It is little bit tricky. You have to understand. If I say Z distribution, CDF means cumulative distribution function. Given a value, I will find out the probability. So here I have given a value, I need to find out the probability. That is, what is the probability of a specific area? Let's say this. This P I need to calculate. Given a value. Value means these values has been given. 680 is my x. Okay, then mean has been given, mu, which is 711, and sigma is 29. Given these values, I will calculate p value. So this is called as cumulative distribution function, CDF, Z distribution. So I will use stats.norm.cdf to calculate cumulative distribution function probability. I will say CDF, these parameters, which is my x, mu, and sigma. And the moment I execute this part, this one, it says 14.25, the same what we get it from Z table. This is the number which we get it from Z table. We just need to pass this number, no need to refer Z table. Everything will be taken care by the Python. Now, similar to that, if you are giving a probability, this is your probability, okay? This is your probability, this is your mu, this is your sigma. You need to find out this point. 680 you need to find out. In this case, probability was not there, but this point was there, x. But here what is happening? This is CDF, cumulative distribution function. This is called as PPF, percent point function. So here what is happening? If you want to calculate the probability, this probability is given to you, which is 0.025. Center point is also given 0 and sigma is also given 1. But you do not have this x. X is unknown. Right? So this part is called as PPF, this is called as CDF. Now, given a probability, if you want to find out this point, for that you need to use PPF function. If you want to calculate probability given x, you will be using CDF function, cumulative distribution function. Right? So let me run this. It says given probability, find the z value. The z value, because we are mapping this with z standard normal distribution. So let me run this. It is minus 1.959. This is my z value, because here mu is 0 and sigma is 1. Here mu was 711 and sigma is this one. Right? So if I take mu, if I standardize it, and if I say mu is 0, sigma is 1, then obviously this value will be this one, which is standard normal distribution. Right? So this is my z value. Similarly, I can also calculate t distribution. And what is t distribution?
Sir,
Yes.
excuse me. Is z value and x value one and the same? Here we are supposed to
Come
find out
again.
x. Is z value and x value one and the same?
See,
Here we are supposed to, in percent point function, as the diagram shows, we have to find out x.
yes. So do not get confused what is happening. Show you. Here what we are doing, I am mapping this value. Suppose this is my x. I am mapping this value with this value. This is my standard normal distribution. This is my normal distribution. If I will standardize it, I am mapping this value with these z values. These are my z values. Because this is standard. Are you getting my point?
Yes, sir.
This there is a standard interval. So I'm mapping these values on these values and I'm giving the name. Here it is x. Here I'm saying z value. So when z value is, let's say, -2, then the value of x is this much. Yes.
Yes. Thank you.
Now on the similar scale, I will calculate t distribution. So for t distribution, given a value, find out the probability, or given a probability, find out the t value. That is t student table or t distribution when sigma is unknown. So let me run this. What is this 139? Anyone remember? What is 139? What is 139? Wake up, guys. Yes. Have you gone through the degree of freedom? N was 140. What is degree of freedom? Hmm? In our case, N was, what was N in when we were talking about T distribution? N was 140. And we know that we use degree of freedom when it comes to T distribution. So if I say the degree of freedom says that N minus 1 will give you the best results. So I will say 140 minus 1, which will give me 139. That is what 139 I am considering as my degree of freedom. Yes. So this is the degree of freedom, and these are my z values and probability. Given a value, find the probability. Given a probability, find out the t value. Sorry, not z value, t values. So I will say stats.t.cdf. If it is given CDF, then I need to find out the probability. If probability is given, I need to find out the t value. Okay, this is something you need to understand. You need to practice or revise it again, else you will get confused. Now here I have the t value. I will be finding probability, that is area under the curve for a specific t value. So it says 97.5%, that is 95% plus 2.5% alpha by 2. So this is the probability for this t value. If I say probability is this much, calculate the t value, then I will be having that this is my t value, minus 1.97. Now the same thing, if you want to go ahead and cross check, with your t table or z table, you will get the exact value. Where probability is this much, you will get the exact value. Here, any doubts in this? Yes, no, any questions? Okay, we'll continue. Let's take a break of 5 minutes and then we'll continue.
The recording has stopped. This meeting is being recorded.
Okay, we'll continue the discussion. So, so far we have discussed about in supervised learning, you have to start with a regression model, right? Again, whatever I have explained it to you, be it, hypothesis testing, this is something a part of master class. But yeah, I find it suitable that I should explain it, so I go ahead and explain it to you. Okay, so now we will start with regression models. Okay, we started with uh, our KNN decision tree, right? Unsupervised we already completed. Now in this is again something extra will be covered in masterclass. We have to start with regression models. Now regression models is something where we apply a equation y is equals to naught plus beta 1 into x1 plus beta 2 into x2 and so on, right? We'll discuss about this. The very first is your simple linear regression. In this simple linear regression, we have y which is continuous and x which is a single variable, right? Like you will be having a data only x and y, no x1, x2, x3, nothing, x and y. One variable, one input, one output. That is called as simple linear regression. When it is multiple linear regression, x become multiple. In multiple, it becomes x1, x2, x3, and there will be single y. So x inputs are multiple, it becomes multiple linear regression. But why, remember, y should be continuous when it comes to linear regression. And why continuous means numerical values. You are predicting those numbers. Earlier you were predicting in classification model, for an example, y is discrete, whether a person will default or not default. Only two options you need to classify. But here we do not have any such option. But you need to predict the, let's say example is price of the vehicle. The number you need to predict, which is continuous. Infinite possibilities are there, right? Then you will be having p value. Again, evaluate p value of each coefficient. And what it says, p value should be less than 5% to say that coefficient values are statistically significant. Now, if you have an equation, in this equation, this coefficient values, when you will use this coefficient values, when this p value will be less than 0.05 or 5%, because industry standard is 95%, right? And using, first you need to check whether p is less than 0.05. If it is less, then only you will validate these coefficient values and you will use it into this equation to predict this y. You will get this y from this equation. And obviously for that you should have this coefficient values. If you have the coefficient values, you can predict y. But you need to check whether these coefficient values are correct or not. So you need to evaluate p value for each coefficient. And when p value is should be less than 5 to say that coefficient values are statistically significant, means you can use it. Then you will also evaluate overall p value, have statistics. This is something we'll discuss later. So this is the thing we have. And there are some model assumptions also we do have. What are the assumptions? Line assumptions. Line assumptions means linearity. X and Y should be linearly related. Y and coefficient value should be linear. Then you will be having plotted versus fitted values. Right? We will discuss these things also. These are the assumptions we do have: independent, normality, equal variance. Error should be independent of each other. Right? So let me open this for linear regression. Regression analysis. What we do? Y, which is prediction of numeric dependent variable. Y, we are talking about Y, which is a numeric dependent variable. So we are going to discuss about equation y is a function of x. Right? Scatter diagram, that is we will compare x with y. If we are talking about simple linear regression, as I said, there are only two variables, x and y. Okay, x and y. X is input, y is output, and y should be continuous. So obviously I can easily plot scatter plot because this is a bivariate analysis. Two variables. I do not have the third variable. Right? Scatter diagram correlation analysis, whether they are correlated or uncorrelated. And this is the equation: y is equal to function of x, or you can write it as beta naught plus beta 1 into x. Or since we have only x and y, so I will say beta into x. There is no x1, x2, x3. So this is a simple equation when it comes to simple linear regression. Then equation of a straight line. Now this is very important. I want data to be on the straight line. That is called as equation of straight line. Then there is something called as a method OLS, which stands for ordinary least squares. Then I have regression analysis, dummy variables, simple linear regression use cases, transformations, bias, and variance. It is a lengthy topic, but yeah, we will spend a lot of time and discuss. So the base equation, we know this is the equation. Given input variables, we will predict y, and y will be continuous. If I talk about scatter diagram or plots provides a graphical representation of the relationship of the two continuous variables. Right? On one axis, I have, let's say, age. On another axis, I have salary or experience, whatever you have. And I can plot that if age is increasing, salary is also increasing. There is some relation. This is called as scatter plot. Now, what should be the understanding? If I'm getting a line like straight, or if I'm getting a line like this, or it should be like this. So there are different possibilities where it comes to scatter diagram, which gives me the relationship between two different variables. So we will discuss about that one. So here it says strong positive correlation. Why strong positive? Because I'm getting the distribution on a straight line, and this is what I want in real world also. The data point should be on this straight line only, because it is very strongly correlated with each other. If this one is increasing by 1 unit, this is also increasing by 1 unit. The straight correlation, this line will be there. But here we do not know what is happening. Is it upside? It is downside? It is parallel? It is like this? We don't know. Hence, there is no correlation. Which one is, if X is increasing, what is happening to Y? We don't know. But with this line or this line, we can understand. From this also, we can get up to some understanding that it was first decreasing and then it is increasing. So that pattern is something we need to understand. That if I am moving one step on x-axis, what is the effect on y? That pattern has to be captured, and we want our regression model to learn this pattern, so that if someone asks a minute number in between this, any number in between this, that given a value, what will be the value of y? So that model has understand this logic, the relation between x and y. Model will easily predict that, okay, this is the value of x, then this should be the value of y, by uh, understanding this relation between x and y. So this relation is very important, and we always want that it should have a strong relation. Now, why positive? Positive means when it is going upward, this is called as positive. When it is going downward, this is called as negative relation. But in both the cases, we have strong correlation. The data point is distributed along a single line. But here, if you will see, data point has been distributed along multiple lines. So if data points are distributed along a single line, then I will say it's a strong correlation. They are very, strongly correlated. They are following a straight pattern. Now here, multiple lines, I will say moderate, because they are not adjusted on a single line. So if it is going down, I will say moderate negative relation, and this one is moving upward, but multiple lines, I will say moderate positive correlation. So this is strong, this is also strong, this one is moderate, this one is also moderate. Positive and negative, 4 relationship we have discussed. This is only between x and y, nothing else. Because scatter plot is a bivariate analysis. When it comes to no correlation, obviously there is no correlation between x and y. As I said, I don't know whether it is up or whether it is down. It is parallel. What kind of direction, we do not know. We do not know. So we are saying there is no correlation. Here, curvilinear. Curvilinear relationship means we are getting like a curve, like this. Curve. That is called as curvilinear relation, in which it was first decreasing and then it is increasing. So we need to identify these types of relations, and this negative and positive are nothing but these are defining the direction of plot or relation. It will represent direction of the relation. So we will judge the strength of the relationship by width or tightness of the scatter. If they are very close pegged to each other, it means it's a good relation. But here they are not closely pegged to each other. There are multiple lines, but here it is close to only one line. Hence we are saying strong relation. Determine direction of relationship. Example, if x is increasing, y is decreasing, it is negative. Similarly, x is increasing, y is also increasing, it is positive. The negative and positive will define the direction. Clear? Any doubt, any question into this? So you have correlation analysis. It measures the degree of linear relationship between two variables. I'm talking about linear, huh? Now we have something called as correlation coefficient. This correlation coefficient is represented by R, and it will tell us how strong the relation between X and Y. The range is from -1 to +1. How good there is a bonding between X and Y, that is something I will get it using this small r, which is your correlation coefficient. Now if it is greater than 0.85, then it will be a good relation. But before that, when you will say perfect positive relation, means it is +1, perfect negative relation means -1, and when there is no relation means it's a 0. If value of the correlation coefficient is greater than 0.85, when R is greater than 0.85, I will say it's a good relationship, strong relation. When it is less than 0.4, when R is less than 0.4, I will say weak relation. Or here, let's say 0.5 is given, but yeah, uh, in this case, it will be a weak relation. And between 0.85 to 0.4 is something you will be having a moderate relation. So it ranges from -1 to +1, exact linear relationship, right? So let me this mind map. Now this is capital R, this is different, huh? Very small r. I think it will be in scatter plot. In your data preparation, graphical representation, bivariate scatter plot, strength, correlation coefficient. Yes. So correlation coefficient, it will evaluate the strength, how good relation between this. The range is from -1 to +1, range of small r. If it is greater than 0.5, it is strong. Less than 0.4, it is weak. And anything between these two is your moderate. And I am taking modulus because it can be positive, it can be negative or positive. Then the analysis, further analysis. So correlation analysis. When R is 0.4, when R is 0, and when R is 0.85. Now, from here you can understand. This is R is 0.4. And what is R? Correlation coefficient. So you can see the distribution is, you can see the distance of this distribution. There is lot of variance, but the direction is positive. So R will be weak. If I will be having a single line and the points will be like this, data points, then I can say it's a strong relation, or might be R will be greater than 0.4. Right? So we can calculate R also and identify the kind of relation. Here it is parallel to 0, parallel to x-axis, hence it is saying 0, but it can be parallel to y also. So here positive relation, no relation, and negative relation, minus 0.4, because it is going down. Here also the relation we need to identify. And this is how it has been calculated using this mathematical formula. Now we have to find out, since we observe that if there is a straight line, then obviously it's a strong relation between x and y. So the equation of the straight line, we do have something, and the equation that represent how an independent variable is related to a dependent variable, and there will be an error term which is a regression model. Basically, this is your equation of a straight line. Beta naught plus beta into x, or beta 1 into x plus epsilon. So this is your error. This equation is called as equation of a straight line. We are assuming that we want data points to be distributed along this line, and this line is called as equation of straight line, which is given by y is equals to beta naught plus beta into x, or beta 1 into x plus epsilon, and epsilon is error. Obviously, if the distributions are like this, the deviation, so this deviation from the mean or average line, the straight line, is your epsilon, or you can call it as error. The data point should be there, but they are deviating from their part, that is error. So beta naught and beta 1 are called parameters of the model, and epsilon is a random variable called as error term. And beta naught is calculated using this, and beta 1 is calculated. These are the parameters of the model. By default, you will get these values, right? Because based on this line, you will be having some intercept value. If you are aware about the line of equation, which is given by y is equals to mx plus c. C is constant. M is the slope of the line. So here this is the intercept value, right? Which will be beta naught in this case. And when you will solve it, you will get this value. So you'll be having beta naught and beta 1. If you put these values, you have x, you will be having error, you will calculate y, which is your output or target period. Remember, equation of straight line is given by beta naught plus beta 1 x plus epsilon. Now you have something called as ordinary least square, OLS method. Suppose these are the data points, and this is my equation of straight line, this one. This line is my straight line defined by the equation y is equals to beta naught plus beta 1 into x. Okay, this is beta naught, which is intercept, as I said, and beta 1 is the slope of the line. If you compare with this equation y is equals to mx plus c, this m is the slope of the line. C is constant and beta naught is this intercept. In your school days, might be you have gone through this equation. Now, what is the error? Error is the distance from the center line to this point, which is deviated from the equation of line. So this is the distance which will be called as error. If the distance is close to this line, here the error is very less, but here the error is more because this data point is far away from the equation of straight line. Right? So I will calculate the errors from all of these data points with reference to this straight line, right? And I will take an average or mean. I will take an average or mean of this distance. And this is supposed to be mean value of y when x equals to x0. And this is suppose x0, x0, and observed value of x when x equals to x0. So these are the different values of x, which is represented by the x0, x1, and so on. The values of x variable, this data point. Now, what this OLS ordinary least squares will do, it will take the distance. How it will calculate the distance from this point to this point? Y2 minus y1. Right, from each of this point it will calculate the distance. Now the thing is that we need to find a straight line by least error. Suppose these are the data points, right? This is a straight line. Now there are multiple possibilities. Straight line can go from like this, it can be like this, can be like this, right? Multiple possibilities are there for the straight line, but I don't know that which line is the best line, which will give me the least square of the errors, or in simple words, least error. Obviously, if I have a data point like this, if I draw a line from here, so here what is happening? If I take this line and assume I have data points like this, or let me assume these are my data points. Now I should draw such a line which is close to all this data point, or I should take this line. Which line is correct? From which line I will get least error?
Close to the
Line,
data.
come again?
Line 1.
Line 1, right? Because distance is very less as compared to this. The distance is more. Yes. So obviously I want that line which will give me the least error. Hence the name is ordinary least squares. It will give me the least error. And that line will be my right fit line of the equation. That will be the right fit line of the equation. And I need to find that line which is going to give me the least errors. But how I will find out the right fit line? So I will calculate the distance from this line to all the points and this line to all the points. Euclidean distance, simple. And whichever line is giving me the least error, obviously I will go ahead with this line. But what this square means, why I'm taking this square? Square means if these are the points, what is happening? If suppose this is the error which is positive, let's say positive 2 units, and here I have the error which is negative. This is positive, this is negative. If I take average, these errors will become 0. Positive and negative will cancel out. To overcome this issue, I am taking square of this average, y2 minus y1 whole square. If I will take an average, 2 and 2, suppose if it is minus 2 and if it is plus 2, this will not cancel out, right? Because when I will do this average, it will cancel out, hence I am taking 2. So the error which was 2, it becomes 4. And negative with positive get cancel out. Now I am getting squares of the error. Hence it is square error and becomes least because I want that line which is having the least error. And the name is least square errors. Are you getting my point? So we need to find out fitting a straight line by least squares. And this is the line we need to find out because there are multiple possibilities. And obviously this line will depend on beta naught and beta 1 values. This and these values. So SSR, sum of variance, or here we can say sum of squared error, which is given by y minus y naught square. And if you combine these two, you will get this total variance. Now you also have something called as R squared, which is called as coefficient of determination. And higher the R2 means, better the model fits your data. It is also called as goodness of fit or coefficient of determination. So these things we will again discuss tomorrow, right? Because if I will explain a lot of things today, you will be confused. So I want you people to do a revision of the regression models. Like you do not have gone through this, but at least get familiar with these terminologies using mind map. At least read mind map, spend some 10 minutes to read the mind map and understand the terminologies. Okay. So I will stop here. These things we will discuss tomorrow.
The recording has stopped.
So if you go through this, you have supervised learning, predictive modeling, and in which you have regression models. So here y is continuous, s is single, then evaluate p-values of each coefficient. It should be less than 0.05, then coefficient values will be significant, that is beta naught and beta 1. Then you have coefficient of determination, which is given by capital R square. If it is greater than 0.8, it is a good model. Less than 0.6 is a weak model. Then you also have something called as small r, which is called as correlation coefficient. The range is given from -1 to +1. If it is greater than 0.85, it is strong. Less than zero point 0.4, it is weak. And between these two is moderate. Okay. A lot of things are there. We will discuss these also. Regression is little bit time consuming because if you will get the familiar with the concepts of the regression, then in second time you will get more clarity. Second means in logistic regression or multiple linear regression, same concepts will be repeated again. So you will not get confused or disturbed with this. This will help you. So I want that we will spend much time on this simple linear regression so that your concepts will be clear when it comes to other regression models. Okay, so yeah, any questions, any doubt, you can ask. What is the status of assignments? What percent of assignments are done? Yeah, speak up, guys. What percent of assignments are being done? Are you working on assignments? Nobody is speaking means what should I understand from this? Yeah, Convam, what is the status on assignments?
I have done some of them.
Some of them. Okay.
Yes.
Mm, yeah. Omkar and Tabish, what is your status?
Sir, working on assignment, sir.
This is because why I'm asking is end of the day, you people will be, in you have to be in hurry and then you have to complete it because you will be running behind these projects. So once your 80% assignments are done, you need to register for the projects and then you will be assigned with a project where you will be working with one of the men. But the condition is 80% assignment should be completed when it comes to project registration. So that is the thing only that you should be simultaneously working on assignments also. On weekends, Saturdays and Sundays, we do not have the classes, so you can utilize those time in completing your pending assignments and simultaneously work on this practice revision part also. Okay,
So
so please
I have
follow
a
this.
I have a question on that. Yeah, is there an end time, like a deadline for this assignment? Because someone like me, work life balance. Even a lot of the weekends, I'm not free because I do rotation weekends. So I try whenever I have the time to do this assignment. But is there a deadline that okay, uh, it has to
The
be?
deadline is 2 to 3 weeks. Within 1 week, we are done with our course. You can complete this assignment within 2 to 3 weeks and submit it.
Okay. So when is our? I don't think I know that. When is our class expected to end in terms of lectures?
Hopefully, within this month, we will complete.
Okay. All right. I'll do my best on the assignments. Yeah.
Hmm.
Thank you.
Hello, sir.
Okay. Yes.
Hello,
Yes, yes.
sir. It's overall 80%, right?
80% minimum.
Also, sir, when it will be the final assignment will be start?
Final assignment will start means
Like its final is project life project or is assignment means what does it mean for assignment?
you don't know assignment means you have not even started working on assignment, Ravish.
Sir, I mean like assignment is like because once we registered on in this course, so salesperson said like it's on we will do end of the course we will do on the life project as well.
That is live project. That is project. Assignment is like your for practice purpose. It is an exercise. Now, without practicing, if you will directly jump into project, then you will
No,
not
no,
get
no.
anything.
That's why you said like you do your like 80% assignment will be done, then it will be enable assignment. So
Ex-
I thought it will be like it's a life project.
No, no, no. Assignment is something. It is already there in your LMS. Once you will complete those questions in assignments, then that is 80% is the criteria. Then only you will be able to register for the live project.
Oh, okay, got it.
Okay. We stop here. Tomorrow again we will connect and continue the discussion.
Sir, I have one doubt. While course structure, they have been told me that for data science there will be 2 to 3 projects, live projects will be working on it. The project will be continuous, or after data science one project and after another model one project like that will be taking place.
Yeah, one by one. Once one project is done, you will get some gap into this, and then you can register for the another course.
Okay, that gap means another course, right? Like Tableau or the AI like that.
Yeah, it's up to you whether you want to go for AI, whether you want to go for project, whether you want to do any other course. It's totally up to you. All the doors are open for you. Are you getting my point?
No, a bit confused because after data science course has been completed, we need to work on project, right? After that, two more topics has been pending, Tableau and artificial intelligence has been pending, I guess so, the cost structure.
WN,
So, Tableau and artificial AI part.
AI, right?
Yeah,
So if you want to work for two data science project, that also you can do. If you want to work on one data science project and then you want to study AI, that also you can do. It's totally up to you
okay, okay,
because there are multiple batches, right?
okay. After completing the this data science, the data science course, after that, after enrolling in project, after that we need to select. After that, we need to continue with projects, or we need to proceed our course in another topics, the rest of the topics.
So batches will be there. If you are available, you can attend the batches for AI. If you want to say that, or no, I want to at least complete two projects and then I will go for AI, that
Okay,
also
okay,
you can do.
okay,
It's
okay.
totally your call.
Okay, okay.
Okay. Thank you, everyone. Good night. Bye.
Good night.